The METUS Tech Show.
Welcome to the METUS Tech Show, a show for HVAC professionals by HVAC professionals.
The METUS Tech Show.
So, Scott, I heard so before the call, right? You mentioned the word Pittsburgher. Can you elaborate that on for me?
Yeah, there's a diner in Pittsburgh. I guess it started in the 20s or 30s called Permane Brothers. It's downtown in a strip district, and that's where all the truckers from all over the country would bring in produce, vegetable, fish, whatever. And being that they're moving at such a pace, they made the sandwiches with any meat, cheese, and then coleslaw and fries right on a sandwich so the truckers can eat. That's awesome. In the 30s.
That's awesome.
All right.
Well, come the 80s and 90s, 2 a.m., everybody from Pittsburgh's at that shop, having it suck up alcohol. And sometimes, it'd be packed until 4 or 5 a.m. But sometime in the early 2000s, they franchised.
Oh.
And they started one in Myrtle Beach, a couple around Pittsburgh, and now they got a couple hundred locations to include 5 in Detroit, a couple in Fort Lauderdale. And it's just like the greatest sandwich ever. You can get hot sausage, steak and cheese, whatever, with the fries.
Sausage. I love hot sausage.
I do too.
Hot Italian sausage.
Oh, man.
Fantastic. Yeah.
Yeah. So anytime you're around Pittsburgh, there's dozens of locations anywhere.
Yeah, but
Detroit.
if you're in Pittsburgh, would you have to go to the original one? Does it matter?
No. Actually, they use the same. It's homemade Italian bread.
Oh.
They keep their supply chain pretty tight. Quality meats, bread, handmade fries.
So,
every location I've been to, the one in Fort Lauderdale, the ones in Detroit, they had identical quality to the.
So what's your go-to meal when you go?
Well, they call it the Pittsburgher, which is their steak.
So it is. That's what you do get. Okay, all right.
Oh, no. I always get 2 sandwiches and eat half of each one.
Smart guy right there.
Italian sausage is probably my second favorite, and then bacon and egg is another good one.
Oh,
see, man. We gotta
get down there.
So we gotta go somewhere that has.
We gotta have a distributor down there. We need to do an inspection or something.
Yeah.
The one in Fort Lauderdale is right on the beach, a block down from the Four Seasons.
Oh,
Team
really?
meeting.
Now I got a question, Scott. Sandwiches are called different things in different parts of the country. Up in New England, we call it a sandwich, or a hot sandwich a grinder.
Yeah.
And then in other places you call it a hoagie, and then you just get a sub. Or it could just be just a sandwich. What do you guys call it in Pittsburgh?
Pittsburgh, well, a hoagie, they call them hoagies, but they're grinders. Hoagies are grinders.
Yeah.
I know it. They got to be,
Never heard that term.
You never heard that, Scott?
No.
Yeah, it's up north where I'm from in Boston. We use sub or grinder.
Interesting.
And if you go south a little more, then they're like, what the heck is a grinder? Right.
Yeah. East or west, rather.
What's funny is Scott's actually up in. You're up that way now, right, Scott?
Yeah. Where the hell am I?
He travels a lot.
Yeah, he does.
Well, New England is just like one big state to me.
Yeah.
You're in Connecticut. Why are you flying into Boston? It's like, I don't want to switch planes, and it's 2 hours. Everything's like 2-3 hours, New England.
For me, though, when I go back to sandwiches, there's something I appreciate with Italian sub.
Oh, yeah. Simple.
If I see it on the menu anywhere I go, that's typically what I get.
Now, cold or hot?
Cold.
Because we do it toasted up.
I don't mind the bread. I do get the bread toasted, but then the rest of the
cheese. Some of the cheese is melted. Some of the meat on there is kind of toasty.
Toasty.
That's the way I like it.
That's another one of my favorite Permanes, the Capicola.
Yes.
Huh?
Yeah.
It's like shoot, but spicy.
All right. Now, is it Capicola or is it Gabagool? Here we go with the Gabagool, right? So if you watch The Sopranos, they go, "Hey, it's Gabagool," and when I go to the deli, I don't know what to say. I'm like, "Can I get a pound of Capicola or is it Gabagool?" But anyway, there was another sandwich place that you were talking about before, Scott. Before we got on this, we were talking about another sandwich, or is that the sandwich place?
Yeah, it's the sandwich place.
That is okay.
Yeah.
So that's the Pittsburgher.
That's the Pittsburgher.
Okay, all right, awesome.
Yeah. So yeah, we gotta put that on the map.
Yeah, we got to do some research on
Yeah,
that.
Scott. Yeah, you would think the whole training team here is we like to eat.
Yeah.
So
Scott, I don't know what he does with the sandwiches that he eats and the food that he eats here on the training team, but he's the thinnest one on the team. Everybody else is kind of...
No. Ralph is still he wins that award now, but just give it about
Ralph,
6 months.
Our new guy, yeah.
Yeah.
So, well, anyway, welcome to the METUS Tech Show, everybody. Myself, Steve Pimentel, and we got Scott Tallman on the call.
Yes.
And we have a special guest, Scott Fielder.
Scott Fielder, yes. He's like what I call our airflow expert.
Excellent.
Yeah, I've known Scott for years now. Yeah, right, Scott? Yeah, wow. Yeah, I've known you for a good bit. Scott, please, why don't you introduce yourself to the callers? Just because this is mechanical trade's a pretty big industry and whatnot. And I always say that you're very, very well known in the airflow industry. So why don't go ahead and introduce yourself and kind of where you've been and then where you're at now.
Sure. My name's Scott Fielder. I've been at this 25 years exactly this summer. Started out in test and balance in Texas the first 15 years. And I was really fortunate with that job. I got to hold a variety of positions, from field technician to field supervisor to trainer to head estimator to then I actually ran the retro commissioning team, which was just fascinating. And then from there, I spent 8 years at National Comfort Institute in training development. And I ran their senior test and balance program.
Yep, I remember. Yeah, I actually attended several of your classes.
Yeah, you were one of the smart ones.
Let's keep it that way.
Yeah.
And where are you at now, Scott?
Yeah, right now I work for Evergreen Telemetry. I'm the director of field operations, and Evergreen Telemetry is an instrument manufacturer. We've been around now for 15 years, believe it or not. We make flow hoods, temperature sensors, velocity grids, CO2 sensors. And my primary job is to go around the country and train people on the equipment. It's wireless. We use the Zigbit protocol, which is similar to Bluetooth, but is a little more secure, as opposed to carrying around a 7-pound meter on a flow capture hood.
Yeah.
Well, flow meters have evolved.
Oh, you have no idea.
Wow.
When they first, when my previous tab company I worked with, we got with Evergreen, you have no idea what a blessing that was.
I mean, it was like Atari back when I was doing it. It was just a big module you held in your hand, and you had to put all these.
Yeah, that's a good example. That's like the Pong of tab, and it's still around. People are still playing it.
Oh yeah, going up and down a ladder. Like if you just you on a job site, I mean, the ladder was your best friend. Going up, going down, going up, going down, hitting the damper. Nope, going back. Oh, I got to open it up. I mean, it's just with the wireless, you're able to sit right there, right on your wrist.
Oh wow!
And just balance it right then and there. So it's kind of nice. All right, so let's now let's talk about airflow.
And I kind of talked to Scott before this. One of the big things that we see, I've been in the trade for about 30 years. I spent a lot of time in the service van, and I worked on a lot of furnaces up in the Northeast. You'd be shocked at, and you're probably not going to be shocked. You probably see this all the time, but I would see furnaces trip out on high limit all the time, and we're replacing high limit switches because they're constantly opening and closing on these furnaces. And the first thing that a lot of service techs do is they go and look at the flame. They thinking, well, this thing's burning too hot, and no one's looking at the airflow, right? You check the filter, yeah, but sometimes furnaces live out their life tripping on high limit, and no one even knows it, just because the airflow was the ductwork wasn't sized correctly. And I just want you to kind of talk about that a little bit, sizing ductwork and what the technician should be looking for, and the installing technician as well when he's setting these jobs up, because a lot of the systems that we're dealing with, Scott and I here at Mitsubishi, and there are a lot of retrofits, and we're going in with our SVZ air handler, which is a variable speed air handler, and they're attaching this to existing ductwork, probably from the 1950s.
And how those are designed were from 0 to 60 hertz. There's no, it's not variable speed. It's 0 to 100%.
Right. Older air handlers with just low, medium, and high speed, and now it's a different ball game. So some of our air handlers don't play nice with existing ductwork. Yeah.
And that's one in between this company, my previous company. I got to work with a lot of manufacturers to include Mitsubishi, Trane, Lennox, Captive Air. and airflow is always an issue. And the one thing is, like you mentioned, technicians are not trained to check airflow.
No.
The first thing any service technician does on a complaint call, hot cold call, is they get their Delta T. You know, and it's like, in cooling, if you're getting 20 degrees split, you're like, oh, I'm good.
Right.
And you walk away. I can't tell you how many service technicians do that. And yet every manufacturer tells you to set your airflow prior to setting your refrigerant charge.
Yes.
It's in all literature.
Yes,
absolutely.
And working with Lennox National Accounts, they told me that 75% of complaints on their equipment are a result of duct design, and installation.
Absolutely.
That doesn't shock me.
Yeah.
All their national account service techs are trained in airflow, which is how I got to know this. Another statistic that they came up with when I was at National Comfort Institute is 70%, at least 70% of all residential systems are undersized.
Oh, wow.
And it goes back to, it's a real good example. David Richardson, who was the curriculum developer for NCI out of Tennessee, or Kentucky, rather. Sorry, David. He calls it Kentucky 2-ton. He walks into a house, counts 8 6-inch drops, and he'll tell you there's a 2-ton sitting out back.
Wow.
The size, 100, because typically you want 100 CFM per ton for a DX system and cooling. And the common thought was 6-inch will get me 100 CFM. And I see that in my job now. I'm all over the country, commercial and residential. I just spent a week in Iowa doing residential service calls.
Wow.
And every single one, you're walking into a house where you're getting 50 to 60 CFM per drop because they're all 6-inch.
That doesn't shock me.
2-ton with 8 drops at 6 inches, and you're damn near freezing the coil.
Yeah.
Because on a DX system, if you go below 300 CFM a ton, you freeze your coil. And a lot of guys walk in and see the frozen coil, and what they do, they add refrigerant.
Yeah, you're absolutely right. And coming from our world, and Scott and I deal with a lot of ductless. So wall units, ceiling cassettes, and one-way ceiling cassettes, four-way ceiling cassettes. That's one thing. But when you get into, we do sell ducted units, and
different game.
And we have small ducted units. We're talking 0.08 static, and the contractors are putting, an enormous amount of ductwork on it. Probably a ton of flex. Flex was designed to be used in 5-foot lengths. It was,
or less.
You're supposed to hard pipe over to the boot and use a short piece of flex. It just got out of hand over the years, right?
Yeah, not in Texas or Florida. You work those states, they love them some flex down there. 80% of the flex in the United States is in one building in Texas.
Yeah.
Yeah, they're like, well, God didn't want us to use all that flex. Why does it come 25 foot to a box?
And you mentioned a lot of systems get undersized. In our world, our systems get oversized, and it's the whole idea that it's a variable speed system. I can put a 5-ton unit in this small house, and it's gonna ramp down, so I don't have to worry about oversizing. Oh yes, you have to size correctly. Just because it's variable speed doesn't mean you can oversize.
Actually, a couple of years ago in Kansas, they were having issues that they're saying their ECM motors wouldn't ramp up. Well, here it came to your point exactly. The ductwork was undersized. Or oversized.
Right.
They couldn't build up the static to ramp up the motors. And they weren't going to reinstall the ductwork. So what they came up with is they had to install dampers in the discharge of the unit.
Oh, wow.
Are you kidding me?
Yeah, doing some kind of like barometric type thing.
Yeah.
Yeah.
It was like total, square peg in a round hole.
Yeah. Now, Scott, let's talk about static, right? So what's good? Can you elaborate the calls? I know a majority of people know static pressure, but let's do a deep dive on some of what measurements they should be taking.
Well, most manufacturers' tables are based off of either total pressure or fan pressure, or total external static pressure. You'll see TESP or TSP, or sometimes we'll say fan pressure. And basically, your total pressure or fan pressure is your static into the fan and out of the fan. That will always be your highest point of static on a system, is into the fan and out of the fan. Total external is into the unit and out of the unit.
And that's how we measure what our total external static is, because we set our fan speeds by static, what the static is.
Yeah.
Now, your total static and total external can be the same value, because say you take a typical residential furnace, it ships without the coil, so it's into the fan and out of the fan. So
Oh, okay. Yeah, that makes sense. Yeah.
and your total static are the same value. Now on a rooftop, they're completely different values. It's into the unit.
Yeah, we know that. Yeah.
Or a package unit, say, not just a rooftop. But so you need to be aware of that. And also, your total external can never be higher than your total or your fan static.
Correct.
They can be the same, but if you're reading it and you get your total externals higher than your total static, something's wrong somewhere.
Okay. Yeah, it makes sense.
Can you give some pointers to listeners on the call how they can determine if the system's, say, undersized or oversized, what they need to look for?
Sure. Well, certainly. And every manufacturer will have a design total external. Typically on residential type furnaces, it was 1/2 inch or 0.5. With the ECM motors, in the average, and I see this all over the country, your average static on a 1/2 inch system is something like 0.84, which indicates you have restrictive ductwork on the suction side and the discharge side. And then you could tell which one's higher as to where your restriction is.
Which way, yeah. And that's what I did when I did investigations and when I was out in the field. That's the first thing I did. I always took a static. Well, let me rephrase that, because I used to do that. Then I realized I needed to go through and open up all the dampers and then go take get my static pressure, and then it'll point me which way to go to where that restriction was.
With Mitsubishi and our ducted units, not our air handlers so much, but concealed ducted units that we sell a variety of different sizes.
Probably one of our most popular units too.
Yeah, there are SEZs and our PEADs.
And the PFYs.
But SEZ, like I said before, is very low static.
0.02 static, I believe.
0.08 maybe, I think.
It's really low.
But it's really low. And I tell contractors all the time, talking highest CFM that unit puts out is 350 CFM. I talk a lot about pressure loss. And you got to be careful what you're putting onto that system as far as how much ductwork you're attaching to it. Nice round turns on your ductwork. Try and keep it all hard pipe because you'll lose a lot of pressure loss with fittings and flex and the type of filter that you put in. Now, if we've gone crazy with filters over the years with these high MERV filters and everything, and I tell them all the time, you got to really be careful with your filters because that's also adds to the pressure loss, right?
Right. No, that's an excellent point. I just had that come up in Pittsburgh, of all places. I was working with the Operating Engineers Union, they're all facilities guys from University of Pittsburgh, Carnegie Mellon, et cetera. And there's all these mandates and, to put in higher MERV. And they're like, how do you know it's too restrictive? And ASHRAE actually has a standard for that. When upgrading the MERV, what they state, and it's you could look it up online for free. They call it the ASHRAE Building Readiness Guide that they came out with during COVID. And it's a great 30, 40-page document. And when it comes to upgrading your MERV, ASHRAE states that you should get a baseline airflow and make sure you're operating around design, first of all. Second, as you upgrade your MERV, you retest the airflow, and you should not degrade your airflow by more than 5%. If I have a 10% drop in airflow, I need to pick a lower MERV rating and find something less restrictive.
I mean, you make a solid point there, Scott, because if it's 10% restricted, right? Think of this. The unit runs for, say, a month, maybe a little bit longer. What's going to happen? Then we're going to have more drop of airflow.
Yeah, as that filter gets dirty.
And that's probably the one, Scott, I'm assuming that's got to be another big topic, right? Filters, for service calls and whatnot, restricted filters for homeowners because they probably didn't replace the filter in 6 months.
Oh, yeah, I've seen some horror shows, and I'm sure Scott's seen some crazy stuff out in the field.
Yeah, that's why I invented the self-cleaning filter. Pull it out every 30 days. You pull it out, flip it around, and put it back in.
I like that one.
Yeah, I had gone to a friend's house, and he was complaining about the home not cooling enough, having all these issues during the heating season. And I asked him. He was living in the house he bought a house, living in it for about 2 years. And I asked him. I said, "Have you checked the filter?" Start with the basics. You check the filter, and he says, "What's that? Where's that?" And I'm like, "Oh, dude." So I ended up going to his house, and I couldn't get the filter out of the filter rack. It was
Just
completely jammed in there, and he was blown away when we replaced it and how much airflow he was getting in the home and everything. So it's got to let the homeowner know where things are, especially when you install. You're going to let them know the frequency in which they need to change that filter and everything. But yeah, duct sizing, load calculations. That's number one right from the start. And like I said, there's a big misconception out there in the field with mini splits and variable frequency systems that you can oversize and the system will ramp down. And that's not the case, especially with
Actually,
Mitsubishi.
That's another huge problem, particularly in the South where you got a lot of like Miami, Houston area. And I've seen it forever where, we're America, more, better, bigger. That's how we fix stuff, is just throw more equipment at it. And my God, one of our clients in Florida, they had a $23 million house in Miami, total Scarface kingpin type place. And I met him on site, and it was oversized by 15 tons.
Whoa.
Wow.
It's a guy, and here's the thing. The owner had millions of dollars of artwork that was getting ruined.
Ouch.
Yeah, because you're not removing humidity at that point.
But their thought was throwing at it. Yeah.
Where he was brought in as a professional witness in a lawsuit, and it started with one development, and they found out the builder, they investigated a couple developments. Every house was oversized by 2 to 3 tons.
On the cooling side, that's
well, it was intentional to upsell systems because they put out the load counts and the manual J for the legal proceedings, and they were putting like 4 people in a room with a TV and a dishwasher. They were just loading the load count because nobody knows what they're looking at. And they go, oh, look, it says you need 5 tons. The whole point of that is once you oversize a system like that, you start raining in the house.
Yeah.
You get these hot and cold complaints, and a contractor will come, again, not checking airflow, saying, oh, your problem is that you're undersized.
Hey, Scott, can we circle back on that? You're saying checking airflow. Can you just give it a generic on go to a house? How would you check airflow? What is your thought process? Like your approach?
Well, because I was raised in industry this way and I work for a manufacturer, of course, I'm going to say use a flow capture. And I'll tell you what, it's amazing. Like I just mentioned being in Iowa, very first house we go to, they had a 4-ton, 16 6-inch drops, and he's hot in the dining room. And we're going around, and all of a sudden my flow hood's getting negative numbers on 2 of the grills. And the guy's like, something's wrong with your hood. I go, it's not my hood. I mean, we just read 14 grills that were positive, and now these 2 are negative. I said, it's something wrong. And here, the flex was disconnected in the basement on both.
Nice. So this basement is getting cold air.
The house is pressurized, air's coming out. And it's coming from the basement, so it's sort of cool. So you take that piece of tissue or a hand, and it feels like you have airflow. And it's actually drawing air down in because the flex was disconnected. And it's been like God knows how long, and it took a $3,000 piece of equipment to discover, oh, you need, 50 cents worth of silver tape to put this back on. A couple of Panduit straps. You're from Massachusetts. You call those flex cups.
Yeah. Yeah.
So again, you would just obviously get your total, right? That's what we're looking for, total CFM?
Well, no, we're speaking just room to room.
Room to room. Okay. That's what you're doing there.
What happens, it comes in, you get your 19 or 20 degree split in a DX and cooling. You're like, oh, your unit's good. You're just crazy cat lady thinking that you're hot or cold in these spaces, And then you walk in, you put the hood on it, and like, where's your cold room? And all of a sudden you go to get 2-3 drops and you're at 300 CFM. And you go to another and you're at 50. And especially, like I said, with all the stuff being undersized, you find that more. Like everyone we put a hood on, it's 50 or 60 CFM when they probably needed 80 to 100 CFM. Yeah, and without a load calc, you don't know. But old rule of thumb for a baseline, and it's published, so it's not just like an opinion, but they would size by square footage, which is not the exact right way to do it. But just to give you an idea, they'd say 0.8 CFM per square foot for residential and 0.9 CFM per square foot for commercial. No, that's by no means replaces a load calc.
No, I know.
But to give you a general idea, just a general concept of what you should be looking at, I always use that going through a house or a building. And now there's all kind of factors.
It's we call it a baseline, right? It's just something to.
Yeah.
A lot of contractors are still using that. Old timers are still out there using that same baseline. It will work to a certain degree, but now, like I said, with variable speed systems, and you got to be really careful, right?
Yeah, and then also Scott too with the collars too. When we're measuring airflow, make sure we put that system to 100%, right?
Override it or trick out the stat.
Oh yeah.
I mean, I used to carry a hair dryer, an extension cord, and a can of keyboard cleaner. Because especially if you're in a
I
building
need you to elaborate on that.
you trick out the steps, especially in a commercial building at night when they go into unoccupied mode. It won't go into cooling until it's 80, and it won't go into heating until it's 60.
Yeah.
The keyboard cleaner comes, you hold it upside down, it comes out at 38, 40 degrees.
Oh.
And it's safe for the T-stat. So you can get the heat to engage.
I remember the one of the first jobs that I did as a tab. I was measuring a building on an RTU, and I was low on airflow. So I had to do a calculation. Now, this particular unit was a belt and pulley. So I had to do a pulley change, right, to speed up the airflow. So I replaced the motor pulley. And it was actually, in fact, it was in Miami, Florida when I did this. And I always remember the jobs that I messed up on, which is very few, may I add. So then I remeasured airflow. Everything came out perfect. And then all of a sudden, the airflow just turned off. I'm like, what? What's going on here? So I go up to the unit, and I turn it back on. It tripped again. I'm like, what is going on? Then again, I didn't see it the first time when I was going through my motions, right, the documentation. But then I see a VFD. I'm like, huh. And then sure enough, when I measured the initial, I was measuring half speed, right? So at 30 hertz, I increased the airflow to what it do to design, and then when it went to 60 hertz, I tripped the motor and all that, and so I had to put everything back to normal. I put and the original motor pulley back on, put the unit at 60 hertz, and then do my measurement.
That's a great lesson.
Yeah. Yes. Yes.
And you managed to do it without damaging anything, so that's even better.
Yeah, you brought up something. I want to circle back on something you talked about. You talked about delta T, and you said something very interesting that kind of opened my eyes to something. You get a lot of contractors that measure delta T and go by that 20 to 30 degrees in cooling. I'm good, right? Yeah. But if the ductwork's undersized and you're not getting enough airflow, you're going to get 20 to 30 degrees delta T. And the reason I bring this up is because as Scott and I, when we teach classes, we discourage just making it a common practice to throw gauges on a system to check performance. Because, when you throw gauges on a system right off the bat and check your pressures, number one, do you know what the pressure should be, right? A lot of contractors, especially now with variable speed systems, it's not like the days of R22 when we used to throw gauges on a system and we had 70 on the low side and 250 on the high side, and you're good, and you got beer can cold on the suction. You can't do that anymore with variable speed ductless units. What we do is we kind of preach and tell them, listen, if you're checking, especially on residential units, not so much on VRF commercial, but on residential units, if you're getting a 20 to 30 degree delta T across that indoor coil, that'll tell you more than putting gauges on a system. Because putting gauges on a system, we can cross-contaminate. We could pull refrigerant out. Those hoses hold quite a bit of refrigerant.
Yeah.
And checking your delta T, that's a good point you brought up. It's not always 100%.
No.
Right? That's not always 100% that system is running correctly. And you just opened my eyes to something, because if they didn't check the filters, if they didn't check the coil, make sure it was, the coil's clean,
blower
wheel's clean, and the ductwork is sized correctly, delta T ain't going to tell you much.
No.
Right?
That's why Scott always piggyback on check your airflow first.
Yeah, and again, going back to the putting the gauges on it, like I said, every manufacturer says set your airflow first before you check your refrigerant.
Right.
And then the other thing is too, and this is on the service calls, especially with new construction, I throw my gauges on somebody else's equipment. I just voided their warranty.
It's become common practice, and we're trying to change that mindset in the field. But I've seen technicians go on just a routine maintenance, and their company will have them fill out kind of a checklist form when they do a routine maintenance, what were the pressures? What, check the amperage, check the voltage, check this. Well, yeah, check your amperage, check your voltage, but leave the gauges in the truck. You should be checking all the filters. You should be checking your airflow. You should be checking your cleanliness of the coils and the blow wheel and all of that first before you do anything. And the other thing I wanted to bring up is when I spent 10 years working in a hospital in the HVAC department with 20 licensed HVAC technicians. And when infrared thermometers came out, it was like the Wild West, man. Everybody had these infrared thermometers. They had holsters on. They would keep these things on them. And it drove me nuts because I'm like, listen, infrared thermometers are excellent, but they're
Just
giving you surface temperature.
Surface, yeah.
And they're pointing these things at diffusers. And you mentioned earlier you had 2 diffusers that were actually sucking air in, and they had nothing coming out of them. And you can put your hand in front of it. Yeah, you could feel something happening, but you don't know if that's positive or negative, right? And, we get a call for a patient room, patient's freezing or the patient's too hot, and they go up there with an infrared gun pointed at the diffuser. Oh, I got 80 degrees coming out of this thing. It's heating. What you're not seeing is that the belts fell off the air handler and all the filters are caved in. Right. So put that thing away and get yourself a thermometer where you actually have to go up to the diffuser and stick it in there. And now you're feeling airflow. And
you're actually taking actual air temps.
Yeah. So that was a great point you brought up about how airflow reacts and behaves. And sometimes you can't tell if it's actually positive or negative.
Yeah. I used to, for infrared, when I was back in the tab, I only used it for one thing. When I went and because I did a lot of troubleshooting on restaurants and, whatnot, fast food places. Well, so half the time we didn't have a layout where, what unit serves where. I have, the RTU might be installed in the kitchen area, but maybe a couple diffusers were in the restaurant area.
Yep.
So what I would do is turn off all the RTUs, turn one on, and put it in cooling or heating, depending on what it is, and get the gun is see which ones, because what'll happen, all the temperature.
It'll give you a quick.
It would just give me a quick reference of what it is. Okay, this is RTU 1. Okay, turn that, and then I would mark it, and then turn the next air handler on. Okay, check it, and then mark it, and so forth. That's the only reason why I would use that for.
Yeah, checking coil temp, checking pipe temp. Stuff like that.
Stuff like that works.
But letting you know whether there's air coming out of that diffuser, it drove us. Now, we almost had to confiscate all the infrared guns.
Now, Scott, so I wanted to ask you, just because you said you were doing some site visit residential, what size were those diffusers or you're looking at?
Diffusers, I don't know, something like 10 by 8, something like that, 10 by 8.
So what type of flow hood were you using?
We make an 8-inch model.
Okay, I was going to ask. I'm assuming you were using the smaller model for that. Okay.
Yeah. We make another model with a 14-inch skirt too that also works for residential.
Nice. Okay, so you guys do also have residential and commercial.
Correct.
Okay.
It's the same hood, but we make different size skirts that are more appropriate.
Okay.
Again, testing and balancing tools and instruments have evolved quite a bit because I just remember the 24 by 24 inch.
The big boy. Yeah, I know.
We used it for everything.
Now, Scott, what happens if we used a 24 by 24 on that smaller grill?
That's an excellent question. Because the flow hoods, whether it's our brand or Shortridge or Alnor or whoever, they're basically designed for 2x2 step downs. And you'll see there's a flow grid at the base. Most of that base of the flow hood that's reading the airflow as it comes through is empty space. So the lower your CFM, the less accurate that reading's going to be, if you follow me, which is why most flow hoods, they'll rate down to 25, 30 CFM, but they're really not that accurate. We only are one model, but we come with inserts on our 3-pounder, which will limit the space. It'll close the gaps on that grid. So you have more airflow being directed over your flow grid.
Oh, so it'll give you a more accurate reading.
Our 3-pound is NIST traceable, which is National Institute of Standards and Technology. They set all the standards in the United States for calibration and accuracy. So when you hear something's NIST traceable, that means you can dial it in and it's accurate.
Oh, nice.
And it's been calibrated.
Are you still using handheld velometers for certain diffusers, like linear diffusers, long linear diffusers? I just remember this from
Yeah, actually, it's funny you mentioned that. I have a whole presentation on linear diffusers, and I started with the operating engineers because the more aesthetic they get in a building, the harder it is to balance and get air.
I remember those things.
And I went to a bunch of different manufacturers' websites, and when I show these on the slides, people are like, "Oh, that's not really a diffuser." I'm going to come right from Titus. They make that. Where you get this S-shaped 8-foot. None of those you can read with a flow hood. And we make a lot of custom skirts, and we're pretty proud of them. But
they do make
an 8-foot S-shaped skirt.
Really? That's incredible.
Yeah.
I just remember two standards. It was just the 24 by 24, and then we had one for linear diffusers that was maybe 36 inches wide.
Yeah, something like that.
By 12 or by 10 or something like that.
Yeah.
But typical sizes are 1x4 and 2x4.
Yeah, that's right.
Wow. Yeah.
But you come to those weird S-shaped linears or hexagons, whatever, phase velocity isn't really that accurate. Years ago, and most manufacturers they'll publish an AK factor where you read the phase velocity out of a grill.
Yeah.
You multiply times that factor, and that's your CFM.
Yeah, you multiply your feet per minute.
In order for that to work, you have to use the exact instrument in the exact same way.
Ah, that makes sense.
Yeah.
And Titus still publishes. There's the TSI Alnor. It was called the 2020 or 2000 Velocinozzle. They haven't made this thing since probably the mid 90s. But manufacturers still publish, and it's actually linears from Titus. And it's dated 2006, and they still distribute it, holding this instrument they haven't made in 20 years at a 45-degree angle to get your feet per minute, your velocity, multiply it times that factor to get your CFM.
Yeah.
And it won't work. I could use a thermal anemometer, a hot wire, or a pitot tube, and I can't use those factors because if those factors are based off of an instrument they don't make anymore. So the best way to do it actually is to make your own factor in the field.
Yep.
Okay.
Correction factor.
And CFM is your feet per minute or your velocity times the area gives you your quantity, your CFM, cubic feet per minute.
I forgot all of those formulas.
The formulas, yeah. Yeah, they're slowly coming back to me.
Yeah.
And the reason I bring that up is instead of using the manufacturer's correction factor, if I get my velocity and then I say traverse the duct where I read my airflow going to the grill, and then I could take that CFM divided by the velocity, and it gives me a correction factor for that type diffuser and that instrument.
Yep. And then from there, you created your own baseline that now you can accurately measure the other grills.
But it's just for that size diffuser and that instrument specifically.
Yep.
Now,
and that's more accurate than using the manufacturers.
Yeah. I'm curious about something. Is traversing a duct still a thing?
Oh, absolutely.
Okay.
Absolutely. And it's the most accurate way.
Yeah, that's when it comes to test and balance, that is the most accurate way.
Pitot tube, 2 hoses to your instrument.
Well, you use a pitot tube. You could use what they call a straight pitot or airfoil.
Yeah, airfoil.
Or you could use what they call a thermal anemometer or hot wire.
Okay.
But you need to be aware of the limitations of each instrument.
Yeah.
About once a year, I get a call from somewhere in like New England or Pittsburgh going, hey, it's always in winter, going, I just installed this 2-ton unit. It should be 800 CFM, and I'm reading 1100. I'm like, what are you using? And it's if you use a hot wire, which is a temperature-sensitive instrument, it sends an electrical signal to the tip, and it determines airspeed based on temperature change. So the quicker the temperature change, the faster the air is moving, basically. But it will not work in heat. It'll throw the instrument off. Every instrument, every manufacturer lists the top range, which is usually 110 degrees to 140 degrees. And I'll tell you, most brands start losing accuracy at 120 degrees discharge. So if I get 140 coming out of that furnace, I'm 20 to 30% off. And I see it every year. Somebody's out there reading something in heat using a hot wire. So it's being aware of the limitations of your instruments and the conditions you're using them under.
That's great advice.
Another one that's perfect is you cannot traverse flex.
What? Come on, Scott.
Yeah, well, it's really funny. Back in the day when I was a pup, I just thought people don't have a correction factor for flex because they're lazy. So I was determined I was going to come up with the correction factor. And I got caught by a general contractor in San Angelo. And he threw me off the job site, made me replace the the run of flex that I was poking holes in and taping over. Just went back on my job site. You better show up with a box of 12-inch to replace that Swiss cheese you just made. And at that point, I decided to abandon the pursuit of coming up with the and agree with the consensus that you can't come up with a K factor for flex.
Right.
That's funny. Yeah, going back to what you said, right? Knowing your instruments and what you're going to use.
Yeah,
I like that.
Limitations of them.
Yeah, limitations. I like that.
Yeah, and the other thing is your accuracy and your range. I mentioned NIST traceable. Now, every service tech doesn't need to have calibrated instruments. However, you should own instruments that can be calibrated.
Okay.
I don't want to knock anybody else's product. And by the way, even though I work for a manufacturer, I personally own Dwyer and Fieldpiece and Testo and our equipment.
Yeah. And each brand has their good, right?
Yeah.
I mean,
we use
them all too.
Brands,
so exactly.
And show them in training and stuff.
There are brands out there that will not calibrate. They're not repeatable. And actually, when I worked at NCI, we were rep for Testo, Dwyer, Alnor, and there were certain instruments that after a couple of years we were selling, we found out would no longer calibrate. Or breaking after 2 or 3 years, and we'd stop selling them and let the manufacturer know. So there's that too.
The same thing goes for in the electrical world with multimeters. Scott and I are always talking to contractors in our classrooms that there's a meter for every purpose, and they're all great, but for our trade, we want technicians to have an HVAC type meter that can give them, all the ranges that they need for resistance and voltage, separate AC and DC voltages. I always preach that. The electricians, they have their own meter. They're taking quick voltage readings. Probably not the correct meter for an HVAC tech, but they all have their own little purpose and job to do, right?
One thing I'd like to point out too. Now, cost is not necessarily an indication of what's best,
right? But
if these three brands cost, these pick volt amp meters, multimeters, a decent one is going to run you $60 to $100. Whether it's Fluke or Fieldpiece, you don't want to buy a $20 meter. I don't care. The good manufacturers don't make anything for $20. My point is, you're dealing with the most expensive system in somebody's building, whether it's residential or commercial. You're about to make a decision that's going to cost them 10 or 20 grand.
That's actually a good point.
$20 meter to make that determination. It's the most expensive system in your building with the cheapest instrument I can find.
Now, Scott, I wanted to go back and think residential, right? So you're a contractor. What would be for those listening, contractors listening on the call? What are some basic necessities that they would need for them measuring airflow? Something that they should have in their van?
Yeah, not necessarily brand, but just the type of instrument they would need.
Number one, you want a good volt amp meter, real reliable and solid. 2, you want a decent manometer that reads static pressure.
Yeah.
And there's multiple brands out there, because you could use that. One way to determine airflow is to use the manufacturer's fan table, which is based off of brake horsepower, static pressure, and RPM or fan speed. Now, a lot of residential models, they pre-calculate your brake horse, which means you just look at your fan speed and your static pressure, and that will tell you your CFM.
And that's how, and Scott, that's how I show them in my classroom. We have a furnace in the classroom, and that's how I show them. I show them real time what it actually looks like, calculating take the static and then matching it with the RPM or the steps, and then putting what the total CFM would be.
Yeah, no, I'm glad you brought that up, because that's a real common error that people make with fan tables, is they only use one value off that table.
Right.
Okay, they'll get their speed or their static and go, okay, I must be moving. It's a triangle. You can't plot without having all those factors. You need all of them. You can't use 2 legs of a triangle, hope it to stand up. The other thing to remember too is that's just a baseline. It's like a rule of thumb, because the manufacturer's fan tables are made in very specific laboratory conditions.
Correct. I preach on that too.
And the moment you put it in the field and you add ductwork or you change those conditions, you're changing that fan table.
And also with furnaces, filters, right? Because a lot of calculations, you got to be careful with that. If it's, as I tell contractors, be careful where you measure static, because if the system is shipped without a filter, well, when they measure that in their laboratory, usually it's not included in that measurement.
Right. And most fan tables will have notes.
Correct.
Somewhere on there that'll say this information is based on 1-inch pleated filter. This information is no filter. Or another one you'll see, this was made with loaded coil or coil and cooling operation. There'll be notes on what conditions they had, and you want to be as close to those conditions as you can be to get a more accurate reading.
Okay, so what other tools should they have, or are those the basics?
Oh, that's the basic. But and then again, really decent temperature.
Yeah,
whether
temperature or whatnot.
Brand, you want to rely on multiple temperature.
Yeah,
because again, one of the things people do is they read the delta T at the unit and go, "We're good." Well, nobody goes and reads the return grill and the supply grill, because I might be entering at the unit at 72 and leaving at 55 or whatever. But then I'm picking up heat in the attic, and I'm coming out of that grill at 65. Nobody ever checks the thermal loss or gain in an attic or basement.
No.
And that's very significant.
Good point.
Especially in older houses where they're concerned about the R value of the building or the flex or the duct. So I might be doing my 20-degree split at the unit, but I'm losing 10 degrees in the attic or basement.
You make a really good point about the return. That's a big one. I see a lot of more undersized returns.
Yeah.
We make a kit, and I know Field Piece makes a kit to where I got 4 sensors wireless. I can read my entering and leaving at the unit and my return and supply grill all at the same time.
Nice.
Yeah, that makes
so you can see
difference.
In real time what your thermal loss or gain is in the attic or basement or crawl space or whatever. That and it's how good you want to be is the other point, Because of course, coming from the tab world, I'm going to own a flow hood.
Well, exactly, and that's what I was going to add on to another additional item for the techs if they're able to get it, is maybe getting a residential quote unquote flow hood, just to measure airflow, whatnot, because that's honestly what I hear a lot is because I get a lot of calls and asking for help, and I always ask, okay, if you don't want to do a static, get your total CFM. And then I said, okay, go match it what your return is. And out in the field, it's amazing. A lot of returns are undersized. So that's a big one.
And Flex has a big...
Turn on the unit, you hear that thump in the return.
Yeah, Flex is a big culprit in that as well. There's every unit gets a piece of 16-inch Flex for a return in the residential world. And I'm talking, and it's...
And another problem you see too is... And even in residential, I just saw this in Florida, where the house was designed out of New York, and it was designed for hard pipe. Well, they build the house in Florida, and they weren't aware of the hurricane code and structural. So now, in order to fit with all the structural add-ons, they had to downsize the duct. And then they put in Flex instead of hard pipe. Of course, it's Florida, Flex and hard pipe, you cannot use the same size. And I see it over and over. They'll replace a 6-inch hard pipe with a 6-inch Flex. You will not move the same amount of air. And you'll find ductulators online that'll tell you what your static should be and and it'll have Flex on one side and hard pipe on the other.
Right. This is all excellent information. I love this episode. Scott, thank you so much for all of this information, your knowledge in this. And I just want to add in one last thing to all the technicians listening out in the field. When you're testing anything with instruments and you're doing any testing, make sure that system, you guys brought up a great point earlier, make sure that system is in 100% test mode or full speed. Make sure your filters are clean. Make sure your coils and your blow wheels are clean. Make sure your dampers are open when you're doing all of this testing, and whether you're doing static, airflow, whatever it is. And
just know some of our units, to put it in high speed, we have the SWE switch to put that fan in high speed. So for our units, yes, look in the service manual for your test run function and
your SWE jumper that for the indoor unit to get that to high speed as well. Because if you're testing it and it's running at low frequency, you're pretty much just chasing your tail, right?
Yeah.
So, Scott, again, thank you so much for joining us today. This is a great episode. I'd love to get you back on and talk some more about airflow.
And
thank you.
And our listeners out there, you guys have any questions, send emails, and then we'll get a bunch and then get Scott back on the call, and then you'll be a great Q&A.
All right, so let's go.
Look me up on LinkedIn as well.
Okay, and Scott, do you want to give a shout out to where you work again, so people kind of know what you have a website that you can give out?
Oh yeah, evergreentelemetry.com is our official website.
Okay, perfect.
Excellent. Going back to the Pittsburgher.
Oh man, you got me like I'm hungry.
Can you
like I said, that's why I always buy 2 sandwiches. I eat half each one, and I'll tell you what, having that thing for breakfast, knowing it's sitting there, it's like cold pizza, man. I love waking up at 6 a.m. and knowing that I got that hot sausage sitting there,
Oh man,
with slaw and fries.
Yeah, the thing is, I'm not a slaw guy. That's one that you probably won't get yelled at.
It's not a sweet slaw. It's not a sweet slaw.
Oh, okay.
And actually, you're a barbecue guy. I love sweet slaw barbecue, pulled pork.
So Scott actually has.
I never liked coleslaw for the longest time, and I'll tell you, over the past 10 years, I've grown to love it. It's actually, it's big with fish and chips.
Yep.
Up in the New England,
Actually, I love putting it on like a cod sandwich.
Oh,
sweet.
Yeah, it's fantastic.
Look at you guys.
Fantastic. Scott doesn't do seafood. Very little.
Actually, Scott actually has tried my competition barbecue.
Okay.
Yes,
nice.
yes, I have.
Yeah. So yeah.
Actually, it's so funny. I went when your old company. I went to do training, and that poor bastard was outside for like 23 hours. I'm like, is he coming in for training? Oh, he don't need training. Cook, Scott. Cook.
Yeah. Yeah. He came in. He was actually given training. And here I'm outside in the parking lot. I was out there for 36 hours, man.
Yeah, that's part of the job, man.
Oh, it is. I love that.
That's more important than anything.
I didn't care. Yeah, I didn't care. Yeah.
All right, we'll see you on the next one. Thanks, Scott.
Thanks.
All right, thank you, gentlemen. See you around.